This is a video about finding the formula and the shape of a complex, and we are told that there's a complex ion formed between the ethane diarate ligands C2O42- and iron 3+, and overall the complex has a charge of 3-. So if I write that a little bit like using the standard notation, so the square brackets to indicate a complex, and it's got iron in it, and it's got some ethane diarate ligands in it. We don't know how many of those, so I'm going to put N to represent a number. We don't know what that is yet. And overall, the complex has a charge of 3-. So we need to work out what this N is. We need to work out how many of the ethane diarate ligands we've got. So the iron we know is iron 3+, and the ethane diarate we know is 2-, and we know we've got some of those, but we don't know how many. And we know overall that gives a charge of 3-. So we've got 3+ minus something makes 3-. So to get from 3+ to 3-, you're doing -6. And you could write this a little bit more like a mathematical expression if you're really confident with maths, and it's fine to do that. But I'm really going to just think it through, and what I've got then is all these ethane diarate ions, however many there are, have got to give us a charge of -6 or 6-. So each of the ethane diarate ions is -2, got to get to 6-, so this N must be 3. So I must have 3 ethane diarate ions in order to get to 6-. So then if I write out my formula of my complex, I've got iron, 3 of the ethane diarate ligands, and overall is 3-. So that's the first part of the question, the working out the formula. And then we need to use this formula to work out the shape of a complex. So what shape this is going to be. So I'll leave the formula of the complex up there. And to think about this, we need to know a little bit more about the ethane diarate ion and how that works as a ligand. And in fact, in this exam question, this ion was given further up in the question, but it is one that is worth knowing. You'll have seen that from the exam questions because there were lots of questions with this ion in it. And you can see in the iron you've got 2 O-. So overall it's C2O4 2-, but you've got 2 O-, and both those O- can form dative covalent bonds to the iron using the electrons, using a lone pair of electrons on the O- ions. So each ethane diarate ion forms 2 bonds to the iron 3+. So each ethane diarate forms 2 bonds, I think I might have just said 3 bonds, 2 bonds to the iron 3+, and there are 3 ethane diarate ligands. So each one forms 2 bonds, and there are 3 of them. 2 times 3 is 6. So that means overall the coordination number is 6. And much like with shapes of molecules, if you've got 6, then the shape is going to be octahedral. So that's really answering the question. You just work out the coordination number and then you think about how those might be arranged. If you're not sure, then you can either give both suggestions or choose one. But with 6, a coordination number of 6, then it's going to be octahedral. I want to just think briefly about how we might go about drawing that if we are asked to draw it, because it's difficult if you don't know where to start to work out how to draw these complexes. So when you're drawing them, always start with the transition metal ion in the middle. And then this one we are drawing as an octahedral complex. Octahedral is 6, so we need to draw our 6 bonds. So 1 up and 1 down, 2 forwards and 2 backwards, like that. And then each of those bonds joins to one of the O- ions in the ethane dioate. So then the next job, once you've got the bonds drawn in, put in the atoms that bond to the transition metal. And then if you've got just monodentate ions that just form one bond, then you can just draw in the rest of the atoms in the molecule or ion in order to finish the ligand. In this case, we've got bidentate ligand. It forms 2 bonds, so we kind of need to draw these up, but that's okay because you just take the oxygens in pairs and you fill in the rest of the ligand. So the oxygen joins to the carbons, and then you put on their double bonds to oxygen. You take 2 more, join to the carbons, put on the double bonds to oxygen, and the final 2, join them to the carbons and put on the double bonds to oxygen. So it looks like it's almost impossibly complex to draw, but actually, as long as you start from the middle and work out, it's not too bad.